Alright, lesson 1 is over gravity and friction. So your vocab slide. A force is a push or a pull on an object. A contact force is a push or a pull on one object by another that is touching it. This should be pull on. Non-contact force is a force that one object applies to another without touching it. Gravity is an attractive force that exists between all objects that have mass. Mass is the amount of matter in an object. Weight is the gravitational force exerted on an object. Friction is a force that resists the motion of two surfaces that are touching. So slide 3, types of forces. A force is a push or a pull on an object, like I said. A contact force, again, is a push or a pull on one object by another that is touching it. So contact means touching. So in this case, it's going to be a push or a pull that's touching the original object. It can be very weak or extremely strong, right? If I'm pushing you, that's probably pretty weak, but if there's an earthquake, that can be part of a contact force, and that's going to be very strong. Non-contact forces are ones that an object can apply to another without touching it. So we have gravity, magnetic force, electric force. Here we have a few different examples. You can see forces up top, and then it divides into two kinds of forces that we're going to be talking about: contact forces and non-contact forces. So contact forces would be buoyancy, where we have the water pushing up on the boat because it's actually touching. Surface tension, friction, again, two things that are touching. And non-contact forces, gravity, electronic forces, magnetic forces, all stuff that you can't really see, but you know is still taking effect. So, slide 5, still with types of forces, strength and direction of force. Arrows are used to show force, just like velocity and acceleration. The length of the arrow shows the amount of force, just like velocity and acceleration. The longer the arrow, the more the force. The direction the arrow is pointing is the direction of the force. So we've talked about arrows before. It's all the same set of rules. The unit for force is a Newton. The symbol for Newton is N. Gravity for slide 6. Gravity is an attractive force that exists between all objects that have mass. Mass is the amount of matter in an object and is measured in kilograms or grams, but the base there is grams. Slide 7, the law of universal gravitation. So the law states that all objects are attracted to each other by gravitational force. The idea was developed by Sir Isaac Newton in the 1600s. Gravitational forces and mass. So if there's more mass, there's more gravitational force. So the bigger or more mass an object is, the more gravitational force. So the mass of the Earth and the Sun are huge on the scale of people, so there's way more force there. Gravitational force and distance. The closer two objects are, the more attracted they are. So Mercury, based on distance, is more attracted to the Sun than Earth is because it's closer. But because it has less mass, it would even out. So again, we are very close to the Earth, touching it, in fact, that the gravitational force there is very, very high. So here we have the force of gravity acts between all objects, right? Object 1, object 2. We are on slide 7, by the way. Force of gravity acts on all objects. If the mass is increased, so you can see that our balloons got bigger here. So if the mass is increased, the force of gravity is increased. But if the distance increases, the force of gravity decreases. So if you make something bigger, it's going to have more gravitational force. If you take two things further apart, they're going to want to get together less. Here we have a picture of Sir Isaac Newton. The quote here is, "You know how things stay on the ground? That's mine. I did that." Continuing with the law of universal gravitation. Weight is a gravitational force exerted on an object. Weight is measured in newtons. Mass does not change unless part of the object changes. So unless part of the object is either taken off or out, or you're adding to the object, it does not change the mass. Weight changes due to the amount of gravitational force. So you have less weight on the moon, but your mass is still the same, provided that we didn't take anything off of you. Alright, so here's our Venn diagram. We have weight can change based on where you are in the universe. Mass stays the same unless something is added or taken away. Both of them, however, indicate how heavy something is. They're both measured in kilograms. Again, we said that weight is going to be measured in newtons. You can measure it in kilograms. And the value for these things is equal on Earth. And that was slide 10. So slide 11, we just have a picture of what's going to be happening if we move from the Earth to the moon. On Earth, our mass is 100 kilograms, and our weight is 980 newtons. And on the moon, our mass is the same at 100 kilograms, but our weight has decreased by a lot because there's not as much gravity on the moon. So again, weight can change, mass stays the same. Friction. Friction is a force that resists the motion of two surfaces that are touching. Static friction is the amount of friction that needs to be overcome to move an object. Sliding friction is the friction between an object and the surface when the object is sliding. So static means still or not moving. So static friction is going to be the amount of force that we need to actually push to get something to move. Sliding friction is to keep something moving. Sliding friction causes objects to come to a stop when you quit putting force on them. And that was slide 12. So slide 13, here we have different examples. No motion, you would have the force is equal to the static friction. For sliding motion, if your box in this example is already sliding, sliding friction is going to work in the opposite direction as the sliding motion to stop whatever it is that's sliding in this case. We're not going to talk about rolling motion or rolling friction, so we'll skip past that one. Friction, for slide 14, fluid friction is friction between a surface and a fluid. A fluid is any air or anything that flows. So this could be air or liquids. Our examples here are air resistance. Remember that you can decrease fluid friction by changing the way that you're holding whatever it is that you're holding. If you've ever stuck your hand out of your car to feel the air resistance there, if you hold your hand up like you're going to give the air a high five, there's a lot more friction and force pushing back on you than if you turn it sideways like you're going to karate chop it. Alright, so slide 15. What causes friction? Microscopic dips and bumps rubbing against one another. Along with the dips and bumps, small particles, atoms, and molecules make up the surface. These atoms have small electrical charges, very, very, very small. Positive and negative charges are attracted to each other, and this causes the slowing of objects. The biggest part, not that the charges don't make a difference, but the biggest part is that the dips and bumps actually rub against each other. So here's a magnified view of a real surface, and very, very magnified. You can't see, obviously we can't see these things, but we have all these little peaks and valleys that as you're pushing something along, they get caught and they rub against each other, and that slows the thing down. So a surface with more peaks and valleys, higher peaks and valleys, is going to be a surface that can create more friction and hold on to something that's smooth. So our rough surface could be sandpaper, but something that's smooth, something like ice, is going to be more leveled off. It's still going to have ups and downs, but it's going to be more leveled off. And slide 17, this is going to be our last slide. Reducing friction. You can add lubricants to the surface to reduce the effects of the dips and bumps. Oil and grease could be our lubricants. Graphite. You can also reducing surface area. That's what I was talking about when I was talking about high-fiving the air versus karate chopping it. If you reduce the surface area, that's going to reduce the friction. And wheels and ball bearings can also be used to reduce friction. And that will do it for lesson 1.